of the system is responsible for holding the control algorithm and other important configuration details. Whatever the memory we have seen in your embedded system diagram or embedded system representation component, it will be having the all the control algorithm and important configuration details with respect to your embedded system function. Okay, for most of the embedded system, the memory or for storing the algorithm or configuration data is of fixed type, which is kind of read only memory. Okay, whatever the algorithms are stored, whatever the configuration data is there, whatever the codes are there, everything will be in the memory area where it should be a kind of read only. Means you can't change those type of data. You can't change the program here. Okay, whatever you have installed as a software, you can't change it. That's why it will be stored as a stored in the memory called as read only memory, and it is not available for the end user for modification. Whatever the use, oh, if you are using the embedded system, the end user can't modify or change anything with respect to the code or configuration data or anything. Okay, the memory is protected from unwanted user interaction by implementing some kind of memory protection mechanism. Memory protection mechanism will be implemented because users, so many different type of users can use this type of embedded system, but they can't if they interfere with respect to the core, if they interfere with respect to the configuration data or not, it will affect the function of your embedded system. For that reason, they have protected the memory area by interaction, by the protecting by interaction of users. Okay, and some protection mechanism will be used to protect the area, memory area. The most common type of memories used in embedded system for control algorithm are OTP, PROM, UEEPROM, EEPROM, and flash memory. These are your one-time memory programming memory areas, that is read only in read only memory. That is one-time programming, programmable read only memory, and UEEPROM represents ultraviolet erasable PROM, erasable PROM, and electrically erasable PROM, and then flash memory. Okay, these are the yeah. Sometimes the system requires temporary memory for performing arithmetic operations or control algorithm execution, and this type of memory is called as working memory. Okay, simply memory can be divided for storage of the code and running of the code. Okay, if you are taking as storage of the code, it can't be changed once it is already installed. Okay, if you are going for running the program, then you need some separate memory area to run your programs. That's why you will get the RAM, that is random access memory. It is called as working memory area. Okay, where you can run your algorithms, you can do some of the operations like arithmetic operation, multiplication, addition, whatever the data you have with respect to that, some operations has to be done. Those operations can be run in this working memory area. Random access memory is used in most of the systems as a working memory. Various types of RAM is SRAM, DRAM, and NVRAM for are used for this purpose. SRAM is for static RAM and DRAM is for dynamic RAM, and you will be having a NVRAM. Non-volatile random access memory, that is your NVRAM. And typical embedded system, apart from these, communication interface is essential for communicating with various subsystems of the embedded system and with the external world. You need to have an interconnection between one device to the another device. When we are telling with respect to the embedded system and memory area, and you will be having the core, you will be having the peripheral devices, you will be having some functioning ICs and all. If we are having all these parts in your embedded system, you need to have a communication between one devices to the another device or one part to the another part. To have that communication, you need to have an interconnection between these internal subsystems also, and you need to have a connection between from one device to another device, internal device to external device by external connections. Okay, that's why you can go with respect to communication interfaces. The communication interfaces may be used to achieve the onboard I2C, SPI, UART, parallel bus interface, etc. Or external communication are wireless interfaces like infrared, Bluetooth, Wi-Fi, etc. These are for external communication. Internal communication are I2C, SPI and UART. With respect to these communication interfaces, we are going to explain or we are going to discuss with respect to this for in further topics also. Okay, don't worry about that. And next is core of embedded system. What will be the core of embedded system? What is the main programming or algorithms will be installed, how you are going to run it, that will be coming under core of embedded system. Core of embedded system are domain and application specific and are built around a central core. With respect to central core, the embedded system will be running. There are domain and application specific are which are built around the central core. The core of the embedded system falls into any one of the following categories. Means whatever the core we are using, that is the main part. And general purpose and domain specific processors are, you will be having microprocessor, microcontroller and digital signal processor. That is under general purpose and domain specific processors. Under this you have three parts, that is, see, with respect to general applications, with respect to like what we have discussed as an example, the electronic toys and all, and smaller application devices, for all those things you need a simpler core device or processors. That's why you will go with respect to microprocessor, microcontrollers and digital signal processors. These are the three domain specific processors used. And application specific integrated circuit, that is ASIC, are used as a core towards the embedded system. And another one is programmable logic devices, that is PLDs, commercial off the shelf components, that is COTS, commercial off the shelf components. These are the devices or core devices which are used to generate or produce your embedded systems. Okay, general purpose and domain specific processor, almost 80% of our embedded systems are processor or controller based. Okay, whatever the 80% of embedded systems are generated, they have processor or they are processor or controller based one. The processor may be a microprocessor or microcontroller or digital signal processor, depending on the domain and application. Whatever the processor we are using, it may be a microprocessor or microcontroller or digital signal processor with respect to the domain and application. What type of application we are using? If I am doing with respect to simpler application, or it is using only for 8-bit data or anything, then you will be going with respect to 8-bit microprocessor or 8-bit microcontroller. If need a control operation also, then you will go for microcontroller. If you are doing some processing on the data, whichever it is given for the given as an input for your embedded system, then digital signal processor will be used. And most of the embedded system in the industrial control and monitoring application make use of commonly available microprocessors or microcontrollers. Okay, most of the embedded system in the industrial control and monitoring application will be using microprocessor and microcontrollers. Yeah. And domain which requires signal processing such as a speech coding, speech recognition, etc., make use of special kind of digital signal processing. For example, if I am taking an speech coding and speech recognition, at that time you need a digital signal processor which will process the data which is given as an speech as an input for this embedded system. That's why you will be using digital signal. For example, we have seen that hearing aid, whatever the data you are getting as an input, that will be amplified and it is given to the user. That's why you will be using a digital signal processor as an core for those type of embedded systems. Okay. And next is microprocessors. A microprocessor is a silicon chip representing a central processing unit, that is an CPU. It acts as a CPU. A microprocessor is acting as a CPU which is capable of performing arithmetic as well as logical operations according to the predefined set of instructions. You have to give some instruction to perform those arithmetic and logical operations. You have add C, and you have subtraction, division, multiplication. All these operations you can do using the microprocessor. Okay. And in general, the CPU contains the arithmetic and logic unit, ALU, and control unit and working registers. You have all these devices, that is arithmetic and logic unit and control unit and working register inside your microprocessor, which will be used or which will support us with respect to the operations which can be done on the input data. A microprocessor is a dependent unit and it requires a combination of other hardware like memory, your timer unit and interrupt controller, etc., for the proper functioning. See, in microprocessor you won't be having a memory and timer unit or frequency generators or timers, interrupt controllers. All those things won't be there. That's why you need a external support like a memory unit, timer unit, interrupt controllers, processing other devices will be added as a peripherals for the microprocessor to get the proper functioning done. Okay. And you can see the some of the example or some of the popular processors which are available in the market, that is Intel, AMD, Freescale, IBM, TI, Cyrix, Hitachi, NEC, LSI Logic, etc., are the key players are in processor market. These are the main processor markets you can see in the market. You can see the difference between general purpose processors and application specific uh, instruction set processor, ASPA. Yeah. General purpose processors. In general purpose processor or GPP is a processor designed for general computational task, that is general purpose processor. Application specific instruction set processor is application specific instruction set processor ASIP or processor with architecture and instruction set optimized to specific domain application requirements like network processing, automotive, telecommunication, media application, digital signal processing, control applications, etc. All come under application specific instruction set. Here in general purpose processor, it is designed for general applications, general computational application that can be taken as an example of laptop, desktop, and typical examples for the general purpose processor. If I am going for application specific, where you can take a device or embedded system device, they are designed only to perform only one type of application. Okay, it can't be done with respect to general purpose operations like calculations or giving an output with respect to the input. No, you here with respect to the specific application like an network processing unit, automotive unit, telecommunication unit, media applications like cameras, video cameras, digital signal processing units like your hearing aid. Automotive means with respect to the controlling sections of your automatic cars. All those things come under your application specific instruction set processors. The processor running inside laptop. Oh, okay. Due to high value production, the per unit cost for the chip is low. The general purpose processors are high volume production is there. For that reason, per unit cost will be less. If we are going for applications specific, most of the embedded systems are built around the application specific instruction set processors. Some microcontrollers like automotive AVR, USB AVR from Atmel, system on chip, digital signal processing, etc. are examples of application specific instruction set set processors. And a typical general purpose uh, processor contains an arithmetic and logic unit and control unit (CU). And ASIPs incorporate a processor and on-chip peripherals demanded by the application requirements, program and data memory. If you are going for general purpose processors, the memory area and whatever the processors are used and what all the peripherals are used, it are those all peripherals are general, means you can't change with respect to the application. But if you are going for application specific instruction set processor, on chip peripherals, whatever the on-chip peripherals are there with respect to memory, what all the requirements are there, what all the peripherals are needed, what all the connections are needed with respect to external device like sensors, actuators, all those things are specific with respect to your application. Okay, that's why application specific on-chip peripherals can be added with respect to your application specific instruction set processor. Next we have microcontroller. A microcontroller is highly integrated chip that contains the CPU and scratchpad RAM and special and general purpose register arrays, on-chip ROM, flash memory for program storage, timer and interrupt control units, and dedicated I/O ports. All these things will be present in your microcontroller. In microprocessor, only processor will be there. Whatever the memory and external timers, interrupt controllers, input output connections, all those things will be connected as an peripheral. Okay, means external connections are needed to perform one microprocessor function. If we are going for microcontroller, you have already CPU, you have a scratchpad RAM, you have a special and general purpose register arrays, and on-chip ROM and flash memory for program storage, timers, interrupt controller units, and dedicated I/O ports. These are with respect to microcontroller. And a microcontroller contains all the necessary functional blocks for independent working, because you can take it as a microcomputer only, because all the peripherals which are needed to run one function or to run any one program with respect to microcontroller is inside your microcontroller. That's why it can be it has all the necessary functional blocks to work independently. Have a great place in embedded domain in place of microprocessor. With respect to microprocessor, microcontroller doesn't need any external peripherals. For that reason, always we can choose a microcontroller over microprocessor. They are cheap, cost effective, and are readily available in the market. Okay, and so many different companies are there where they will produce the microcontroller, that is Atmel, Texas Instrumentation, Toshiba, Philips, Freescale, NEC, and Zilog, and Hitachi, Mitsubishi, and Infineon, and ST Microelectronics, National, and Microchip, Analog Devices, Intel, Maxium, Sharp, Silicon Laboratories, and TDK, and Trisend, and Winbond, etc. are the key players in the microcontroller market. So many different companies, still more different companies are there where you can see different type of microcontrollers from different type of companies. You can see the difference between microprocessor and microcontroller here, where you can define, or you can tell that microprocessor is a silicon chip representing a central processing unit which is capable of performing arithmetic as well as a logical operation according to the predefined set of instructions. With respect to predefined instruction sets, we can run the micro programs on microprocessor which can perform arithmetic and logical operations. If I am going with respect to microcontroller, a microcontroller is a highly integrated chip that contains a CPU, scratchpad RAM, special and general purpose register array, on-chip ROM, flash memory for program storage, timer and interrupt controller units, and dedicated I/O ports. That is related to microcontroller, means it has all the peripherals which are needed with respect to the functioning of arithmetic and logical operations. And in microprocessor, it is dependent unit. It requires the combination of other chips like timer, program, and data memory chip, and interrupt controllers, and for functioning all those things. That is dependent unit. In with respect to microcontroller, it is a self-contained unit. It doesn't require any external controllers or timers or UART, etc. for its functioning, because everything is present in your microcontroller only. Most of the time, general purpose is design and operation. In design and operation, with respect to microprocessor, it is a with respect to functioning, it is a general purpose design. If we are going for microcontroller, mostly it is application oriented and domain specific with respect to microcontroller programs or codes, and doesn't contain a built-in I/O port, and the I/O port functionality needs to be implemented with the help of external programmable peripheral interface chip like 8255. See, if you want to give any external input towards the microprocessor, always you don't have any built-in I/O port. That's why you need external I/O port To function that external IO port, you need an external programmable peripheral interface chips like 8255. And most of the processor contains multiple built-in IO ports which can be operated as a single 8 or 16 or 32-bit port or as individual port pins. That is with respect to microcontroller. If I am considering with respect to microprocessor, targeted for high-end market where performance is important. If I am going for microcontroller, targeted for embedded market where the performance is not so critical. With respect to microcontroller. And in microprocessor, limited power saving options compared to the microcontroller. Here in microcontroller includes a lot of power saving features because see, if I am going for microprocessor, you have so many external peripherals to control or function with respect to the external devices or external peripherals. You need to have a power supply for all the external devices. To power saving option will be very less compared to the microcontroller. Okay. Digital signal processor DSPs are powerful special purpose 8 or 16 or 32-bit microprocessor designed specifically to meet the computational demands. Okay. And DSP are powerful special purpose 8, 16 or 32-bit microprocessors designed specifically to meet the computational demands and power constraints of today's embedded audio, video, and communication application. Normally, whenever we are going for digital signal processors, always it will be with respect to the processing functions. Wherever you need a processing function like audio processing, video processing, image processing, and communication application. Normally, with respect to communication applications only, we need these type of processing application. Okay, and digital signal processors are 2 to 3 times faster than a general purpose microprocessor in signal processing application. If I am going with respect to microprocessor or general purpose microprocessors, compared to that, this digital signal processing processors are faster for signal processing applications. Okay, this is because of architectural difference between these two, and DSP implement algorithm in hardware which speeds up the execution, whereas general purpose processor implement the algorithm in firmware, and the speed of the execution depends primarily on the clock of the processor. As I told you, you can see the difference also here, where DSP will be running the algorithms in hardware. Okay, whatever the algorithms with respect to the processing of the signals are there, you will be running them in the hardware because you will be having the processing hardwares also with your digital signal processors. And whenever you are running the algorithms in hardware, the output will be very fast. It will speed up the execution also. And if you are going for general purpose processor for processing of your signals, then whatever the algorithms are there, you will be running on the this one firmware or software. Okay, that's why the speed of the execution will be slow compared to your DSPs. Okay, audio video signal processing, telecommunication and multimedia applications are typical examples where DSP is employed. All for telecommunication and multimedia applications, you are going to do audio or video signal processing. Digital signal processing employs a large amount of real-time calculations. Okay, always it needs a large amount of real-time calculations, like whatever the FFT, DFT, sum of product calculation, convolution, fast Fourier transform, discrete Fourier transform, etc. will be performed. Those calculations you have seen already in fourth sem or fifth sem, fourth sem I think you were having signal processing function, signals and system. There you have seen these, or DSP you have seen this for fast Fourier transform and DFTs, sum of products and convolutions and all. These calculations can be needed with the large amount of real-time calculations, okay, etc. are some of the operations performed on a digital signal processors. This is related to your digital signal processors.